This is the second part of the video. So this is what the distribution of the favorite policies of voters looks like. Now let's bring in the candidates into this. Okay, so remember the candidates A and B, they want to announce policies, but they care only about winning elections. Okay, now we assume, let me just go here, we assume that candidates can commit to their announcements, okay, after winning the elections, after winning the election. What does it mean to have this commitment power? It means that, so first candidates announce their policies. Candidates A and B announce some number between -1 and 1, each of them. So that's what it means to announce policies. Then voters vote, and whoever gets the more votes wins the election. But then they have to implement, like whoever wins have to implement a policy, right? Here we are assuming that when candidates announce policies, they have the commitment to follow through on their announcement. So whoever wins will actually indeed implement the policy that they had announced before the election. Okay, this is a simplifying assumption. We can relax this and try to see what happens when there are no commitment power. What happens when politicians face future elections? Does that create some kind of commitment within the model, etc.? So those are sort of more complicated questions. In this model, we want to very simply look at some sort of very basic forces at play in election and how that can be captured using game theoretic concepts. That's why we want to sort of bring the model down to its sort of bare minimum simplistic version. So that's why we are assuming that when candidates announce policies, voters understand that these announcements are indeed in some sense credible, right? So whoever wins will actually indeed implement the policy announced, right? So voters don't have this dilemma that, well, I'm voting now based on the announcements, but maybe the politician after winning the election will do something different. So that concern we are sort of removing by just by assumption, by saying that candidates have this commitment power, okay, to follow through on their announcement. So how does the game proceed? As you probably have guessed, so candidates A and B announce two number PA and PB. So these are policy announcements. Policy announcements. Then voters vote. Then the winner is decided. And the winner implements implements the announced policy, implements her previously announced policy. So that's the idea. That's the sort of sequence of events. Okay. So important thing is that they make this announcement, and this announcement determines who will win, because voters will vote based on after observing which candidate announces what, right? So think about candidate A as Joe Biden and B as Bernie Sanders. Okay. Now let's go back to the graph that we had. Right now, let's try to think how voters will vote. Okay, voters are situated on this line -1 to 1. Different voters are situated differently, right? Think about all these different voters who are situated here. How different voters will vote based on what PA and PB are. So think about PA is some number here, and think about PB as some number here, right? So think about A, so the A candidate announced some number which is sort of to the left, on the left side, and B announces the policy which is more to the right, right? So say B is more right wing and A is more left wing, let's say. Okay. But they care only about winning elections, right? Now the question is, who will vote for which candidate? Think about a case where everybody votes, right? So everybody has to vote. Now for a voter which is around here, so consider voters to the left of PA. For these guys, PA is much closer to their favorite policy. So suppose think about this guy. So for this guy, PA is much closer than PB. So he would like the candidate A to win election, because if candidate A wins election, A will implement a policy PA which is still not his favorite policy, but at least it is closer to his favorite policy than the policy PB that the candidate B will implement if he comes to power. Okay. So for this candidate on the left, PA gives him a higher payoff than PB. Okay, so then he votes for candidate A. So that's how voting decisions are decided. Okay, so for each candidate like this, even for this candidate, PA is much closer than PB. Okay, so you can therefore see that all the candidates which are to the left of PA will all vote for candidate A. Similarly, think about a candidate which is to the right of PB. So think about voters who are even more right-wing in their ideology than the policy announced by B. For those guys, they would rather have policy B being implemented rather than this far left policy PA being implemented. So for these guys who are to the right of PB, they will vote for candidate B, right? So all these guys to the right of PB will vote for PB. What about guys in the middle of PA and PB? For them, they have to think which one is closer, right? So suppose think about this guy. For this guy, again, PA is closer than PB, so this guy will vote for PA. But for this guy, PB is closer than PA, so they will vote for PB. So basically, there will be a midpoint here for whom PA and PB is equidistant, right? So that guy is indifferent between voting for PA and PB. All people to the left of this middle point will vote for PA. All people to the right of this middle point will vote for PB. Okay, So then we can get the vote shares by drawing this vertical line. So we can find out the region of this distribution function. So this is the share of voters who are voting for PA, and this is the share of voters who are voting for candidate B. Okay. So for any PA and PB, notice that PA and PB are choices made by candidates A and B. These are not fixed numbers. These are chosen. These are endogenous variable. I'm just showing you what will happen for a given PA and PB chosen by the two candidates. For any two such choices, this is how voters will vote, right? Voters vote, whose favorite policies are closer to PA vote for candidate A, whose policies are closer to PB vote for candidate B. Okay, and that's how you calculate the vote shares. Okay, and whichever is greater will win. So let's say in this case, suppose the shaded region for A is bigger than the shaded region for B. Okay, so in that case A will win, right? If this is clear, now let's try to find out how are the incentives of the two candidates to announce different PA and PBs. Okay, so that's where the calculation lies. Let me just draw this graph once again. So this is -1, this is -1, this is +1, and this is the distribution. Notice, let me go back to the graph. Notice that suppose now fix PA. So suppose A announces PA. So they both announce their policy simultaneously. Okay. Now suppose A announces PA. Now suppose B, instead of announcing this PB, announces something here. This is, suppose instead of PB, B announces PB prime. Okay, he announces a policy which is much more to the center. Okay, what will happen? Let's try to think it through. It is still the case, by the same logic as before, all the guys to the right of PB, these guys, these guys will now still prefer to vote for B than for A, because for all these guys PB is nearer to their favorite policy than PA. Take any of them, take this guy, for him PB is closer than PA. Okay, so all these guys will vote for B. Okay, all guys to the left of PA, these guys will still vote for A. What will happen to the guys who are in the middle of PA and this new PB prime? We again have to find out a middle point. Let me draw it in yellow color. So now the middle point is somewhere here. Oops, let me change the coloring. Yeah, so suppose the middle point is here. Now all these guys indifferent between voting for PA and PB. All the people to the left of this colored point, the middle point, vote for PA. All the people to the right of this new colored point vote for PB. So now how does the vote share shift? So now I'm drawing a vertical line. So now candidate A's vote share is this, candidate B's vote share is this. Okay, and therefore you see that fixing A's policy at PA, if candidate B changes his own policy from PB to PB prime, candidate B's vote share goes up. It used to be a smaller region under the graph. Now it's a bigger region under the graph, right? I'm fixing So I'm fixing A's policy, and I'm trying to think what would B do. So as you can see, as B moves to the center of the distribution, he gets more votes, because now there are more people who find B's policy to be nearer to their favorite policy than A's policy. So this vertical dotted line, that also moves to the left. That moves to the left. Okay. Given this, we can now move to this. Sorry. We can now move to this graph. So think about now any same PA. Sorry, think about that same PA. What would B do? Okay, B has to get more than B's objective is to get more votes than A. Okay, and suppose I'm fixing A at P. Now let me define an object of the distribution. So suppose this M is the median of the distribution. M is the median of the distribution of voters' favorite policies. What does the median distribute? What is the definition of median? Median tells me median is the point on the distribution, the right of which 50% of observations lie, and the left of which also the 50% of the observation lie, right? So if B announces a policy which is at the median, if PB is this median policy M, then you know for sure that all these guys to the right of PB will vote for B by the same logic as explained before, because for all these guys, B is this policy M is nearer to their favorite policy than PA. Okay, so then all these guys, this shaded region, will vote for candidate B. Now you see that by announcing a policy which is equal to the median of the distribution, you ensure that at least 50% of people vote for you. How I know that? Because this shaded region is 50% of the observation, right? Because by definition, median is the policy, median is the point, the right of which 50% observations lie. So 50% of voters lie to the right of M, 50% to the left. So all this 50% will vote for candidate B. Okay, and that means by announcing this median policy, B will ensure that B will win. If you get 50% of votes, you win for sure, right? At least you get 50% of votes. There are some people to the right of him who will also vote for you, right? So your vote share is now more than 50%. So for any PA that is on the left of M, PB, the candidate B, can always announce PB equal to M and ensure that he wins. Okay. Similarly, by the same logic, if PB is something different, so PB is if PB is here different from this M, then candidate A now announce here PA equals M and ensure that 50% of votes go to A, and then A will win for sure. So if any of the two candidates announce something different from M, then the other opponent candidate can always announce M and get at least 50% votes. right? Just by the fact that M is the median policy, and hence if you pick M, if you, one side of the voters distribution will all vote for you, okay, which is 50%, right? So this tells us that this tells us that announcing policies PA or PB which are not the median policy. So if you announce policies which are not M, if PA is not M and PB not M, ensures that the opponent will win for sure, okay? What happens if you actually announce M? So suppose PA is M, then if PB is not equal to M, then if PB is not equal to M, then B loses for sure. Why? Because if PB is not equal to M, let's go back to the diagram. If PB is not equal to M and PA is at M, then PA gets this 50% of votes. So A wins for sure. So B loses for sure. So if A announces M and B announces something different from M, B loses for sure. But what happens if B also announces M when A announces M? If PB is also M, then both candidates announce the same policy. This implies that all voters are indifferent between the two candidates. So imagine Joe Biden and Bernie Sanders announce almost identical policies. So then from voters' point of view, there is nothing distinguishing between the two candidates, right? Apart from their personal characteristics, which people may care about. But here in this model, we are assuming that voters only care about policies. So they get payoffs only from policies. So they only look at policies announced by the politicians. And so if both candidates announce the same policies, PA equals M and PB equals M, then if I go back to the graph, both PA is M as well as PB is also M. So they are both here. So then all voters are indifferent between A and B, right? For any voter considered to the left or to the right, voting for any of the candidates gives them the same utility because they have the same policy, right? So then they vote for any of the candidates with probability half. All voters vote for any of the candidates. Each of the voters basically toss up a coin and vote for one of the candidates. So then the votes are split half-half. And so there is a tie. So any one candidate wins with probability half. So basically this implies that each candidate gets half of the votes and hence wins with probability half. Okay, notice that's the best thing that can happen for any candidate, because if the candidates don't announce the same policy, which is the median policy, if any of the candidate moves away from the median, that candidate loses, because the other candidate gets more than 50% of the votes, right? And so if you announce the median policy, I know if I announce anything else other than the median, I lose for sure, because you are getting 50% of the votes, because you are in the middle. So that makes me move to the middle and make me announce the same policy. So my best response when you announce the median policy is also to announce the median policy, and vice versa. When I announce the median policy, it is your best response to also announce the median policy, which means that PA equals to M and PB equals to M is indeed a Nash equilibrium of this voting game, right? Because they are mutual best responses. Okay, and that's the definition of Nash equilibrium. So what we have found that in this specific model of voting, where there are two candidates who are only interested in winning elections, and there are voters who have their favorite policies on this policy spectrum running from -1 to 1, we find that in Nash equilibrium of this game, both candidates announce the same policy, which is given by the median policy. This is a very famous result in political economy known as the median voter theorem. Median voter theorem. The median voter theorem says that that the electoral competition between candidates, when candidates are only interested in winning elections, will force them to choose the same policy given by the median voters policy. Okay, so if the voting the favorite policies of the voters change and the distribution changes, then the median will also change, and hence the equilibrium will also change, right? So suppose for whatever reason, suppose all voters become very right wing, right, because of say propaganda and the media narratives, etc. For whatever reason, if all voters favorite policy move a little bit to the right, then the whole distribution moves to the right. Okay, and then the median also moves to the right. If the median moves to the right, if median voter theorem is true, then you should expect in equilibrium candidates pick more right-wing policies, because they also follow the median. Okay, they track the median. If the median of the distribution changes, the announced policies of the politicians will also change. So this is the idea of median voter theorem, which is an result we get by applying the concept of Nash equilibrium in this model of elections. Okay, I'll talk about a sort of a general takeaway from this kind of models of competition in the next video.